Hi, I'm Shipra Agrawal. I'll talk to you today about reinforcement learning. Let's start with understanding what is reinforcement learning. Reinforcement learning is characterized by an agent continuously interacting and learning from its stochastic environment. Imagine a robot moving around in the world and wants to go from some point A to point B. To do so, it tries different ways of moving its legs, learns from its successful motions as well as from its falls, and finally finds a most effective way to walk. Reinforcement learning is a branch of artificial intelligence that formalizes this trial and error method of learning. It is essentially the science of making sequential decisions. How should the robot move its limbs so that it can eventually learn to walk and reach point B quickly? More generally, how should the agent interact with its environment? What action should it take now so that it learns about the environment and is more successful in future? One of the things that make reinforcement learning special is that it sits at the intersection of many disciplines of science. In all these different fields, there is a branch that's trying to study this problem which is same as reinforcement learning, the problem of making optimal sequential decisions. In engineering, it is the problem of finding optimal control. In operations research, it is studies as dynamic programming. The algorithmic principles behind reinforcement learning are in fact motivated from a natural phenomena behind human decision making. In simple words, that rewards provide a positive reinforcement to our actions. This phenomena is studied in psychology as conditioning and in neuroscience as reward systems. Now let's look at a few things that make reinforcement learning different from the other paradigms of artificial intelligence and machine learning, like supervised learning methods. One of the main characteristics of reinforcement learning is that there is no supervisor in reinforcement learning. No labels telling us what's the best action to take, but only reward signals that enforce some actions more than the others. Going back to the example of robot trying to walk, note that there is no supervisor telling the robot that whether the actions it took were good or bad. But it does get some signals in the form of the effect of its actions, whether it moved forward or fell down, which it can use to guide its behavior. Other major distinction is that the feedback is often delayed. The effect of an action may not be entirely visible instantaneously, but it may severely affect the reward signal many steps later. In the robot example, an aggressive leg movement may look good right now, as it may seem to make robot go quickly towards the target, but a sequence of limbs movement later, you may realize that that aggressive action made the robot fall. And time really matters in reinforcement learning. The sequence in which you make your decision will decide the final outcome. And finally, as you can note from all these examples, that the observations or the feedback that the agent obtains during a reinforcement learning course are not really independent of each other. In fact, they are a function of agent's own actions, which the agent may decide based on its own past observations. This is very unlike other paradigms like supervised learning, where the training examples are essentially independent of each other, or at least independent of the learning agent's actions. These are some of the key characteristics of reinforcement learning, which differentiate it from other branches of learning and also make it a very powerful model of learning for a variety of application domains. Now let's concretize this discussion with some examples. We have already discussed the example of a robot trying to walk. A more general example along the same lines is automated vehicle control. Imagine trying to fly a helicopter, learning to perform stunts with it. Again, no one will tell you a particular way of moving the helicopter is good or not. You may get signals though in the form of how the helicopter is looking in the air, whether it's crashing or not, and in the end you might get a reward. A high reward for performing a good stunt and a low reward for crashing it. Using these signals and the final reward, a reinforcement learning agent would learn a sequence of maneuvers just by trial and error. Some of the most famous successes of reinforcement learning has been in playing games. You might have heard about Gerald Tessaro's reinforcement learning agent defeating the world backgammon champion, or DeepMind's AlphaGo defeating the world's best Go player Lee Sedol using reinforcement learning. These systems figure out how to win the game just by playing the game again and again, trying out different strategies, and learning from their own mistakes and successes. A slightly different application is medical treatment planning, where the problem is to learn a sequence of treatments for a patient based on the reaction to the past treatments as well as the current state of the patient. Again, while you observe some signals in the form of the immediate effect of a treatment on patient's condition, the final reward is whether you could cure the patient or not, and that's available only in the end. The trials here are very expensive, and therefore in this application the trials need to be very carefully performed to achieve the most efficient learning possible. Another application very popular currently is chatbots. You might have heard of Microsoft's chatbots Tay or Zoe, or intelligent personal assistants like Siri, Google Now, Cortana, or Alexa. All these agents trying to make conversation with a human user. Now, what are conversations really? They're essentially a sequence of sentences exchanged between two people. Again, a bot trying to make a conversation may receive encouraging signals periodically if it is making a good conversation, or a negative signal in the form of a human user getting annoyed or leaving the conversation. A reinforcement learning can use these feedback signals to learn how to make a good conversation just by trial and error. And after many, many conversations, you might have a chatbot which has learned the right thing to say at the right time.